had a couple requests for a video about these probabilities. And in general, when I'm talking about probabilities, chances are what you're talking about is a random walk. And all a random walk is really it just imagines that you're moving about kind of randomly within the graph. So let's think about what that might look like. Imagine we've got dude here at A, and dude is going to start just walking randomly. Well, A doesn't leave you a whole lot of choice in this case, right? Like, there's only one place for me to go. I can only go to B. So I have a 100% chance of, if I am leaving A, for sure, that I'm going to end up at B. From B, though, now I have a whole bunch of different places I could go. In this case, I could start on this path, which would bring me down to E. I could go back to A, certainly. I could go to E this way. I could go to C. I could go to D. I've got a whole bunch of options from here. In fact, I have 1, 2, 3, 4, 5 different paths that I could end up taking. And so the probabilities really are going to be in fifths. So let's start building that transition matrix. Remember, when you're building a transition matrix, you're going to have your from B up here and your to down here. So as we're looking at A, we're going to look at what is the probability that I move anywhere down here. Well, the probability I end up back at A is 0. There's only one thing here, so it would B would be 1, and then the others would be 0. From B, however, I have 5 possibilities, and one of them is to take me to A, so 1/5 of this could take me to A. 0 could take me to B. There is one path leading from here to C, so I got a 1/5 here. To D, I also have a 1/5, and notice to E, I have this path and I have this path, so I have a 2/5 chance of getting down to E. Important to note here also is that this column sums to 1. 1/5, 2/5, 3/5, 5/5, you get a total of 1. Obviously, this one will also sum to 1. From C, I've only got 2 options, so I could go to B, so half of my choices will lead me to B, half of them will lead me to D, and I can fill in zeros. From D, I have 3 options. One of them is to B, one of them is to C, and one of them is to E, so I have a thirds there. And from E, I also have 3 options, but 2 of those 3 options lead me to B, none to E, or none to A, one of them to D, and none back to E. So every column sums to 1, and this is really just the probability that if I started at B, so in fact, let's pick a thing to talk about. That one right there. This is the probability that if I start at D, that I end up going to C, which you can see, whereas if my dude ends up down here at D, the likelihood that they're going to move over to C, they've got 1, 2, 3 paths to go, and if they're choosing randomly, there's no like candy over at C or something to like draw me over here. I have a 1/3 chance of traveling, traveling up to C. Okay. So there's other questions we could ask now. For example, if I start at E, so I just happen to be over here, what is the probability I end up at C after a walk of length 2? Now, this is certainly a possibility. I could go over there. I could go that way. I could do that. All of those end up at C, and they're walks of 2. But of course, my walks of 2 don't have to get me there. I could go here and here. I could go here and here. I could go here and here. I could go here. I mean, there's tons of different options here, and it's a lot to figure out. Now, if you have a super specific question like this, you can just think through the probabilities, right? I could definitely count and say like, okay, the only ways I could do this is I could go start at E, go through D, end up at C. I could start at E, go through B, and end up at C. And in fact, those are my only options. The trick is that to get to B, I have 2 different ways. I could go this way or I could go this way. And you can work out the individual probabilities of this if you would like. But a much nicer way to do it is just to look at the square of this matrix. However, just to make sure that we know what we're doing, we're going to figure it out this way, and then we will compare it to the square over here. So let's deal with this first one. What's the probability that I move from E to D and then up to C? Well, the probability that I move from E to D is going to be 1/3, because there are 3 equally likely paths here. One of them gets me to D. Okay, cool. I'm over at D now. What's the probability that I end up taking this path to C? Well, that is also a probability of 1/3. So the likelihood of just that happening, 1 out of my 9 options, is that. The probability that I start here and I take up to B, both of those will get me there. So I can say that that part would be 2/3. And then the probability that I then, when I am up here at B, that I end up taking this path down to C, there are 1, 2, 3, 4, 5 of those. That is a probability of 1/5. And that gets me the probability of 2/15. Then to figure out the sum, I'm just going to add these together. So 1/9 plus 2/15 is 11 out of 45. Or 2 and 4/100 repeating. So now what we're going to do is we're going to look at this thing squared. I'm not going to do that by hand because that sounds disgusting, but I will do it in Desmos matrix. Here is the result there. This was my original matrix. This is the squared matrix, and you will notice starting at E, ending up at C, that's going to be right here, because this would be E, and this is C. And that ended up getting us exactly what we calculated. So that's the idea. And then obviously as you raise this to higher and higher and higher powers, like for example, a to the 200, notice that all of the columns all the way across, I'm getting the same number for all of these. What this is telling me is basically like I have been wandering just randomly in this thing for so long, right? I've walked across 200 edges at this point. What this is basically telling me is that in the long run, 7% of the time, 0.07, I'm going to end up spending my time at A. 35% of the time, I'm going to be at B. Hopefully that makes sense. I've got a lot of connections to be here, right? 14% of the time, I will be at C, and then both E and D are equal. I end up spending about 21% of my time there. So this is just kind of like the long-term repercussions. This is shorter term, just like after 2 or 5 or 10 or whatever. The likelihood that you'd end up there. Let me know what questions you have.